now I want to modify this code to illustrate other language features. So here we used a constant size array. So it's a little bit wasteful of memory because sometimes we may get a n only 10 or 20. Now we are allocating a 1 million size array. So that's kind of bad practice. So this is something, this kind of allocating static size array is something very common in actual competitive programming, because you just write a small program, solve a problem, and then you're done. But in real world programming, you don't really do that. So instead of you will want to allocate the array just of the right size. So let's do that. And by doing that, I'm also going to illustrate some important language features. It's sort of the semantics of one thing is semantics of parameter passing in function call. So let's get rid of that. So we have now we're going to declare a vector of Boolean let's call that seats again. The size is n. So since we are declaring this, we actually can provide a default value. Let's say the default value is false. Then we don't need to do this. So so now we're allocating of the right size and then assigning it. Then this next, now this seats need to be passed in because it's not a global variable here. So let's do vector seats. So then when we call this function, we pass in this seats and do this. Okay, so now anytime we call next, we pass in seeds. Is there another next? Yeah, I think it should be one at the end. Okay. All right. Okay, so let's try this. Okay. And yeah, we need n is not declared now. So then, because we pass in this this is a sort of a structured thing. It knows its own size. So n is really just this guy's size. So this is one way to do it. Just directly put it here. So my habit is to create another and put it like here. So in old times, this is actually a valuable optimization, because if I have this seats.size here, this will be this seats.size need to be evaluated every time this function call, even though it's a very low overhead function call, it will be evaluated every time I do it. But by assigning to a variable here, I'm just directly accessing that variable. But I think modern compiler can optimize that, so they can figure out this size actually doesn't change here. So this shouldn't give a performance difference. But let's just use this nonetheless. And also, we're not changing n, so we might as well add a const here, just for fun. Okay, let's run the code again. Okay, it passed all this, and then let's submit. Hey, it passed. I actually didn't expect it to pass. Okay, so I did some experiments. So let's try this again. So I added a new test case. So I realized the test case I have seems to be not big enough in order to achieve my goal. So let's try and see whether this works or not. So let's first open the editor. So this is the same code. Let's submit it and see whether we added a new test case. It's a bigger one. This one actually has a 10 million input. So hey, finally we timed out. So but maybe that's because the it's too big. So let's use our old version. So I copied this, saved this code here. So this is the old version using the static array. Let's see whether this need to open in editor. Try the hey, this one passed. Well, it does take longer, 1.48 seconds, compared with these are 0.13 seconds. The other are kind of all lessened. But and the input file is a 10 million actually 10 million bytes. So let me just show you. You can see this is the input file. This is the it's quite big. Did I add 2 more there? Anyway, okay. Oh, I guess this is because the input 11 is really less than what I had intended. Okay, so I should be able to do. Anyway, so now the question is why this code pass and the other code doesn't. So what's inefficient or in the other code? So let me copy that code back here. Okay. So the main reason that inefficient is because of the way this function call is written. Because C++ use C and C++ use a call by what's known as a call by value semantics. So when you call this function, you're actually copying those variables and then make a copy of the value of your variable and then assign them to here. So where's it? Yeah, so this is my first call. So this 0 is assigned to here, true is assigned to here, but this seeds is actually a copy of these seeds is made and then assigned to here, so that if you do things to the seed here, it will not affect the value here. So this is this value that is being copied. So this when n is big, we are copying a big vector every time. So we need to allocate new memory and then copy the value. So this is going to be fairly time consuming. So one way to fix that is to tell the compiler, we don't make a copy, just use whatever value that's used to call this. So to do that, you add this ampersand here after the type. So this tells them, the compiler, the data type is a vector of bool, but actually don't make a copy, just use the original, the one that you use when calling this function. So this is called call by reference. So this tells the compiler to change the call semantic from call by value to call by reference for this value. So let's try this again. So that's, we're basically making this a single character change. What's wrong? Maybe, oh, maybe I didn't. This one still have the. Let's first see what are the output. What did I change? Did I make some change to this? Oh, okay. So this was yeah, something I was testing. Added. This was I was testing this to see what was the reason that it didn't generate the failure I intended. So added some code, printed something extra. Okay. So let's run this again. Okay, then submit again. Come on, yes. So yeah, 1.58 seconds. So it's slightly longer than the first version, but it still passed. So by making this one character changes, we are actually dramatically improve the runtime. So the code that I deleted was counting how many times this function was called. It's a lot. So when that happens, without this, they will be making a lot of copy of that big vector. So with it, then that's not so that's the key thing I want to illustrate is this call by reference. Now to further illustrate this, I want to change this function again. So so I want to change this function to illustrate. We can use call by reference to primitive type as well. So instead of returning the value, I can directly update the value that you pass in. So by telling the compiler, this int variable, also don't make a copy of the integer value and then pass it here. Just directly use the whatever variable that that they call it. So when I do I++ here, I will be actually changing that variable. So this will change the way we use the next. I will need to pass. I cannot pass a constant value in. I have to pass in a variable. So the int start at 0. So that should be. So I need to change. So essentially, this int variable will be directly updated by this function. So yeah, so actually I written my code in the way so that this will not change much. Let me actually illustrate this. Yeah, let me actually illustrate this by adding this. So yeah, so let's print out the first indice value here. So let's run it. So we will not pass anything because we printed. So let's look at this. See, so for this, because we have 3 0, we are looking for first 1. So the value int actually updated to 3 after this call. However, if I do not have this, if I just have this here, if I run it, then the int value will be all 0. So first int is 0, first int is 0, first int is 0. So all the first int is 0. So that means what that means is these function, even though I use this int to call this function and have I here, the change to I has nothing to do with here, because what happens is the value of int is copied to the value of I. So I and int are two different variables. They correspond to different memory locations. So when you increment I, the int doesn't change at all. But by adding this ampersand, I'm basically, the compiler will know anytime I'm referring to I, I'm actually referring to the variable that calls it. So let's see whether this. Okay, now it passed, and then submit again. Okay. So I think this is the final version I want to show to illustrate this usage, this call by reference. So here, this usage is critical. If I do not do that, then a lot of copy will be made, and it will be inefficient. Of course, if I really don't want to do that, I can declare a global variable. So let's actually do that as well, just to show different way of doing things. So I can declare a global variable seeds. So then I will not need that. And now I need to initialize the. Actually, let's try something else. So because at this point, this array already seeds already exists, this vector. So to resize. To be honest, I'm actually not totally sure resize is the right function to do it here. Let's see whether it works. And then what we need to do is I need to get rid of the seeds from all the function calls of next. There's one more here. Okay. Okay, it works. So, so these, what happened is I have a global variable seeds, and because I didn't provide any special initialization, at this point the seeds actually is an empty one. So, but here I know what size I want, so I can call this. If I do not have this, I should run into memory errors. So let's actually try that. If I do not have this, then at this point seed should still have size 0. So when I'm accessing seeds, any of these reference, they actually reference to things that don't exist. So yes, see, reading symbol for, so this is just a segmentation fault. So this happens when my code reference a memory that doesn't exist, and this it happens in this this square bracket, this referencing the vector. So because at this point the vector still have a size 0, and I'm trying to accessing indices with the different indices. So I need this to resize, to allocate the memory for seeds. But this allocated once, and then this variable is used in here. Okay, so I think that's it for topic 3.